Hey guys, thanks for joining us. I'll start sharing my screen here, and I am very excited to do this multi-cloud CI/CD with failover using Kubernetes and Istio and Helm. This is a talk that I was able to give recently at the Seattle Kubernetes meetup, as well as the San Francisco Kubernetes meetup, back to back, and it was actually a lot of fun, really exciting. And for those that are asking, yes, we are going to do all this stuff in a live environment. We're going to hands-on keyboard, do some terminal. We're going to run pipelines. We're going to show how these clusters work. So it's going to be very hands-on, but we'll also explain sort of conceptually how it works. So I'm glad you tuned in, and let me share my presentation. And and I think everybody can see my screen, and holler in the chat if you can't. I will just remind you as we go through this, there is a QA section on your Zoom where you can ask questions. Please, as we go along, put questions in there because it's more for us to respond to, and it's a lot more fun when people are asking questions and engaging. So like Taryn said, I'm Dan Garfield. I'm a chief evangelist for Codefresh. I've been doing Kubernetes and Istio and Helm for a while now, and my background is a full stack engineer, and so this stuff is all really exciting to me. So it was a lot of fun to build a multi-cluster, multi-cloud setup. So I'm excited to share that with you. So just to introduce kind of why I'm doing this on behalf of Codefresh, we are a Kubernetes native CI/CD platform. We have about 20,000 users and people like ARM and Giphy. If you've ever watched a video on adultswim.com or CNN.com, you're using software that was built using Codefresh. They use our CI/CD to build all that stuff. So that's why we care, because we are super concerned with Kubernetes and Helm and kind of all of these what we call cloud native technologies, whatever that means. Cloud native technologies. That's sort of our bread and butter. So that's where we come from. So let's talk for a second about some things that happened semi recently. There have been some outages that are caused by a variety of things. In this case, Stuart here can't turn his lights down because if this, then that was down. So that's kind of a bummer. It's never fun when people can't use your service. This one's pretty good. It's getting they can't adjust the thermostat because Nest was down, and it was because of an S3 outage. So this kind of stuff is disappointing, but I think my favorite of all of the outages tweets is this one. And I'll let you read it. I'll give you a second to read it. So I can hear you chuckling at home. This is pretty great. The idea that you can't turn off your oven because of an outage. Now, that probably points to some architectural problems with your technology. But the bottom line is that downtime stinks. Nobody likes it. There are a lot of reasons why a Kubernetes app might fail. Maybe the cluster is out of resources. Maybe there's a bad configuration. Maybe there's a node failure that's not being addressed. And a lot of these things can be mitigated with a multi-cluster, or what I'll introduce as cross-cluster setup. So let me explain how multi-cluster works, and then we'll get into the, I see these messages. People are very anxious for us to get hands-on keyboard here, and so we're going to do that. But a multi-cluster setup, what you do is you have two clusters. Now, they could be on different clouds. They can be in different availability zones. One could be on GKE and one could be on-prem. One could be a Raspberry Pi cluster sitting in your basement, and one could be Azure, AKS instance. Doesn't really matter. The basis is that you have two clusters. And in multi-cluster, you have sort of a master cluster, which is going to be, in this case, cluster 1. And then you have all of these sort of clusters available for it. In this case, cluster 2. And you can see here, I think you can see my mouse, the cluster 1 has a full Istio control plane installed on it. And cluster 2 only needs a partial control plane. And really what this is doing is cluster 2 needs to be able to handle some networking, and it needs to be able to handle pod injection, and a few little things that Istio needs to function. But once you have those two things set up, and as a side note, these two clusters need to be on different subnets, meaning the pods actually need to have IP addresses that are all routable to each other, and so they cannot have collisions with their IP addresses. Now, if you've ever tried to change the subnet on a Kubernetes cluster that has already been set up, you will know that it is basically impossible. You basically have to set it up properly from the beginning. So that's something to be aware of as you go to maybe replicate this. But once you've done that, you're going to connect the clusters with some kind of VPC. Now, it could be a VPN tunnel. Google has a cool technology called proxy IP that they use that makes this subnet thing not an issue. And basically, your goal here is you just want pods between two clusters to be able to reach each other. That's it. And once you've accomplished that, and there are a lot of tutorials out there on how to set up a VPC or set up a VPN tunnel between clouds, and that's kind of the area of this that I don't want to focus on today. But once you have this set up, you can route, you can have pods talk to each other. And now what we're going to do is we'll introduce our application. And a Kubernetes application is made up of a couple of components, right? We have our service, we have that talking to a deployment, and that deployment describes a set of pods. Now, in a multi-cluster setup, what's going to happen is your user's going to come in through cluster 1 to this Istio control plane, and that's going to route them to this service 1. Then service 1, because we have the cross-cluster setup going on, is actually going to see deployment 1 and deployment 2 as if they are on the same cluster. So this is part of Istio's service discovery capabilities. Basically, it makes the service 1 think that deployment 1 and deployment 2 are on the same cluster. And so it treats them as if there were just 2 deployments on cluster 1. Now, all of your pods in deployment in cluster 1 can die, but your deployment will still work from cluster 2. In fact, Istio is smart enough that even if your service, deployment, and pods all were deleted from cluster 1, they would all just route from cluster 2. Now, this is called multi-cluster. It's based on some work that Cisco did and added into Istio, which is pretty awesome. Now, to go a step further, and some of you might already realize this. Hey, I can hear you saying, Dan, it seems like there's a limitation. People have to go in through cluster 1. Well, sort of. If they come in through cluster 2, they won't ever be routed to cluster 1, but they can consume cluster 2. Now, if you want them to act the same, then this is called cross-cluster. Okay, so this is multi-cluster, right? Which is I have one cluster that sort of controls these others and serves up content from other clusters, but the networking always goes through cluster 1. Cross-cluster is basically everything is like cluster 1. Everything has a full control plane and also can route to the separate clusters that exist. So I hope that makes sense. And if it doesn't, it should soon as we get into demonstrating this. So just before we get into demonstrating it, what are some of the use cases for why you would want to do this? Well, one use case on the left here, multi-cloud, multi-region. Maybe you just want to mitigate outages between of individual providers. Like you want to have an AWS plus GKE plus AKS cluster setup. And AWS and AKS can go down, but it's not a problem because you still have something running. Or across regions, right? You could use a single cloud provider like Azure and have AKS clusters in multiple regions, but have them connected together with either cross-cluster or multi-cluster setup, as I've described. And I should add a link at the end of this for a tutorial on how to set up the multi-cluster portion. Another use case would be a hybrid on-prem. And this is, I think, one of the most common that I've seen is that a lot of organizations want to have a cluster that they own, that's like bare metal. Like it's I know where the server is. I can go and hit the power button on it and reset it if I need to. Maybe it's an old school server and they've got a turbo button. Never remember that 486 days? Get that turbo button going. Well, anyway, they've got their on-prem cluster, and then they just want to have a cloud cluster that's honestly probably less expensive and can scale more dramatically, faster, easier. And so they want to have those two clouds interplaying together, but ultimately, if one goes down, it's not a big deal. The users aren't interrupted, and there's not an outage, certainly not a catastrophic outage. Another reason is cost mitigation. So I don't know if you can see this icon. It's a guy making it rain on the clouds, you know, spending money on the clouds. Well, there are these great things out there, and there are a lot of blog posts about this recently out there that are basically preemptible instances. So on AWS, they're called spot instances. On GKE, they're called preemptible nodes. On AKS, I don't remember the name, but basically what they are is they are unreliable resources. So for example, on AWS, if you get a spot instance, you're going to pay pennies for that instance compared to what you'd pay for a normal EC2 instance. But the downside is that spot instance can disappear at any time. Now, if you're running a single node app and it's just sitting on an EC2 instance, you're saying, I can't ever use a spot instance because I can't have it be unreliable. However, if you're using Kubernetes, if you're using a cross-cluster or multi-cluster setup like this, you can have preemptible nodes, spot instances for nodes, and you don't really care because if they die, it's not a big deal. So that's another reason to do this because you can sort of mitigate costs and not have to worry too much about nodes disappearing out from under you. It shouldn't be an issue. Okay, now let's talk about CI/CD, and I just see that there's a question that somebody asked, that is this being recorded? It is being recorded. Well, we will give you a link and a link to the slides and some of the tutorial aspects of this so that you can go and reproduce some of it yourself. And well, I'll talk about that later. So let's talk about the CI/CD stuff. So the purpose of continuous integration, continuous deployment, or continuous delivery is that we want to make software development as much like an assembly line as possible. Now, that doesn't mean we want, as engineers, to feel like we're working on an assembly line. We don't, right? We want to feel like we're masters of the universe creating amazing software. But you want the experience of making a commit and having to get to production be mundane. You want that to be reliable and repeatable every time. And moreover, and this I don't have a poll for this, but ask yourself, can you make a commit on Friday afternoon, push it to production, and go home and sleep easy? That's the goal, right? That's the goal of a good CI/CD setup. So I won't belabor that point, and we'll get into it. So a really good CI/CD tool should marry all of these things together: Docker and Kubernetes, Helm and Istio, so that they're all working in tandem to make your life easier and make your application more reliable, and also help you just build software faster, right? Because it's not as hard. There's not as much overhead to operating these things. So let's talk about the multi-cluster rollout process. And this is what we're going to do today. We're going to make a commit. It's going to do a multi-stage Docker build. Why does it need to be multi-stage? For those that don't know, and this is actually fairly common, people that are not doing a multi-stage Docker build will often include build tooling in their Docker image. And this is especially common with Java, very common with Go, and people end up with these like 2 gig images where 95% of that is build tooling. Like, this is terrible. Don't ever do that. So you want to be able to do some sort of multi-stage build so that you can parse out those elements. Anyway, that's a whole nother video. Then we're going to build a Helm package, and we're going to deploy it both to cluster 1 and cluster 2, and we're going to deploy it to both concurrently so that they're both available. And then we're going to start our Canary validation leveraging Istio to direct traffic a portion at a time until we've reached 100% of traffic, at which point we will do a final push to cluster 1 and cluster 2 to remove the original instance of the application that's not being used anymore. So that's how Canary works, and that's how the multi-cloud Canary works. So maybe what we'll do, I'm just thinking that I want to demo this, but I want to show the Canary. Let's just explore the multi-cluster here for a second. So what I've done here is I've got an application called Colors. And you can see that cluster 1 and cluster 2, by the way, I'm in Codefresh, both show a Helm installation of this application called Colors. Now, this is an application that I've developed to demo this stuff. And you can see that they both were modified 20 minutes ago, right before this demo. I just kind of reset everything. But they do have different revision numbers, and that's because of some of the stuff that I'm doing in this demo. But if we open up one of these, let's open up one. We'll see that there is only one service exposed. Currently, only one replica is exposed there. And we can actually just scale that up really quick. And we can do that on the other one. There is we can see the history of all these that have gone on. We can do rollbacks. We can see the charts. Let's go back and look at all our Helm releases again. And I'm going to scale this one up as well. This will just make it a little bit easier when we start killing things, because that's part of the demo. All right, so we see these two instances of our application. And in fact, what I've done here, let me open one of these really quick. So this is the application Colors. Here's what it looks like. It's just a screen that shows a single color. That's it. It shows the path that was requested. Now, the only thing that I've done differently with this is that I've added the ability so that when I click on it, it will kill the pod. And that's because we're going to use this for our health check, and it'll make sense as we go along. So just to demonstrate, when I click on it, it'll kill the pod, and it'll say, whoa, that pod that you're trying to reach is gone. And we could actually mitigate this so that the user never even saw it with some tips, with some tricks with Istio, but we didn't do that here. So this is how it works. Now here I've got basically a bunch of iframes, and these iframes show me what the user is seeing. It's basically just loading the app a bunch of times, and currently everybody is seeing blue. Now, like I said, these are in two different clusters, cluster 1 and cluster 2. And so half of the instances you see here are actually coming from cluster 1, and the other half are coming from cluster 2. And to demonstrate this, we're just going to try editing one of these deployments. So I'm connected right now to cluster 1, and we're going to pull open this deployment, and we're going to modify it so it shows a different cluster. It shows a different cluster, a different color. It shows a different color. So we're going to edit that. And what I've done is I've set it up so that I can just pass in an environmental variable here. And here we go. Containers. This is where we want to edit. And let's put it right here. So I'm just going to add an environmental variable to this deployment, and we will give it a name. It's called color, that's what it's looking for. And then we'll give it a value of red. And if we write that, this will edit it. Now here I'm basically bypassing my CI/CD process. This is for demo purposes only, so that you can see how the rollouts are functioning here. And if we get the deployments, we'll actually see that it looks like it has finished. So now, okay, now we're seeing half of our instances are red. What does red represent here? It represents cluster 1, blue represents cluster 2. To go back to this diagram, right? We have a full service deployment and pod stack on both clusters. We just changed cluster 1 pods so they show as red. So this is a demonstration of how the multi-cluster works. Now, if we modify this deployment, for example, let's delete this deployment. And we're just going to delete the deployment that we just modified. And will we see a service interruption? For those playing along at home, you should all be shaking your head, and you would be correct. Everything shows up as blue now. Why does it show up as blue? Because we killed the deployment on cluster 1. Now that that deployment is gone, it automatically just fails over to cluster 2. So so this is how that's functioning. Now we're going to reset this before we do our rollout. So I'm going to open up my chart here and look at the history. And what I'm going to do is I made those changes, by live editing it. So I'm going to do a rollback to the current version. This will erase all my changes and put us back to square one. So we'll let this rollout happen, this rollback happen. Now, while that's happening, I have a brief question and answer for you. And I'm going to launch this poll. If you wouldn't mind answering some of these questions, it'll be valuable as we go through here. And again, please feel free to ask questions as we go along in the Q&A. And most of these I'll answer after a few minutes here. So this rollout's running, and it's probably just about done. Let's see where it's at in the process. Oh, it is done. Okay, so now if we get the deployments, we'll see that the deployment is restored. It will not be red because the original rollout wasn't red, right? I edited it to make it red. So let's do that one more time. We're just gonna edit again, and we'll make it red so that we can watch the rollout happen when we do an actual CI/CD work. I am using VI, so I apologize for all the snobs in the room. Why aren't you using Emacs? Because I don't like it, that's why. Oh yeah, how do we do this? Name, color, whoa, gotta type it right. Value, red. And I'm pretty sure I did that right. So let's write it. And it should already be coming back up. Now you notice that the number of pods that I have has gone back down to 1. Why? Because we set it back to the default state. All right, so now we're getting half of those red. Let's go back to our Helm releases, and let's scale this one back up to 3. Oh, good. So somebody's giving props to the usage of VI. Thank you for that. I appreciate it. All right, so we'll just scale that up really quick, and we'll have 3 pods going. So about half of what we're getting will come from cluster 1. You notice that there's a little bit of variance there as pods became ready. No big deal. So again, cluster 1 is red, cluster 2 is blue. We're now going to kick off a change and see what happens. Oh, and there's a cool, well, we'll show that in a second. So to introduce how a Canary works, let me show you just a couple slides. For those that aren't familiar with Canary, and we're going to do it fairly quickly, basically, I have a blue version of my application. This is called my prod version. This is not, blue is called prod. No, it's my production version is going to be the blue one, and my Canary version is going to be yellow. And basically what we do is we start off with everybody getting the prod version. Now, in this case, we've modified prod, right? So that cluster 1 is red and cluster 2 is blue. We're going to make both of them yellow as we change it. But we start off with everybody getting the prod version. We deploy a Canary version, which will be yellow. We then start sending a portion of traffic to that yellow version. Now, you can do a Canary release using Kubernetes. We actually have a built-in sort of deploy image just for doing Canary to Kubernetes. So you can grab that and use it in your Codefresh pipeline. to do a Canary rollout with Kubernetes. But with Istio, you can get a lot more granular with that Canary. You can say, I only want my own employees to be part of the Canary release. So it's segmented by users. You could segment it by geography. You have a lot of options there for how you route that traffic. But at any rate, we're going to send a portion of traffic to the Canary version. We're going to do a health check, and as it looks good, we're going to increase the amount of traffic it's receiving. And if it continues to look good, we'll send everything to the Canary version. If it still looks good, we'll go ahead and remove the old prod version, and the Canary version will become the new prod version, and we're set up for the next release. So hopefully that makes sense. And we'll go ahead and end that poll. And it looks like the question I had that I wanted to share was on Istio, which is that about 50% of you are working on adopting Istio, with about 9% having already, already sort of adopting, and the rest not sure yet. And so that's very helpful. Thank you. So we're also going to, I'm going to issue another poll here in a second to see if we'll fail our Canary release. Now remember, I made it so that when I click on my app, it kills the pod. So the health check I've set up for the Canary release looks at how many times pods have died. And if pods die too much, it will roll back, it'll cancel the release and roll back to square one. It will remove the Canary version of our application. So that's what we're gonna do right now. We're gonna modify our app, and we're gonna make the color yellow. So I'm gonna modify the code here. Now this will be overridden by an environmental variable if I have one set. That won't be a problem, because when we issue this release, it will actually, it will create a new release for my chart, and it won't have that environmental variable that I set. Go yellow on both clusters at the same time. Okay, now this is going to fire off a commit into GitHub, which is going to fire off a webhook into Codefresh to actually build, push, and deploy this. So what we're going to see is we're going to have, remember, red is cluster 1, blue is cluster 2, yellow will be cluster 1 and 2. So we actually will have sort of like 4 sort of instances, basically 2 on each, right, on each cluster. So, whoops, while we do that, this will build, and once it's built, it'll create that Helm chart, and it will fire off actually 2 separate pipelines to run simultaneously. I basically have a templated pipeline for my deployments, and so it can just fire that off from any other pipeline. It'll fire off 2 at once, 1 to cluster 1 and 1 to cluster 2, and we can get into kind of how that, how you configure a pipeline like that in a second. This Docker image that it builds will be a multi-stage build, so that I have a really nice small image. My service, my pods start super fast. And I have another poll to ask, and this one is about the Canary release. So we'll have a question here, which is, should we make the Canary release fail and roll back to the version that we have now, or should we let it go all the way to finish? Most of the time, 90% of the time I do this, people say, kill the pods. I want to see the Canary fail and roll back to the previous version. Every once in a while, there's somebody says, no, I just want you to let it finish, let it happen. But go ahead and fill out that poll. You can see that it's now kicking off the Canary release to happen on both clusters at the same time, and then it will start the validation process. So it looks like most people, though not as many as I would think, are saying break it and let it roll back. And it looks like the let it go, I want to see the rollout finish, loses the vote, though more narrowly than usual. So I like this crowd. They're a very orderly kind of crowd. They like to see things working properly, not break. But we're going to make it fail. Okay, so this release is finished. this one's going to finish up in just a second, and now it's going to start the Canary validation. So let's jump in and see where we're at. It's going to update to 35% of the traffic to get the yellow one. So there it is. There's 35% of our traffic is getting the yellow one. However, you guys voted to kill it. It is narrow though, 54%. So we'll kick it off when we're done, and we'll let it go. All right, so let's kill this thing. And the way we're going to do it is I'm just going to click on all these yellow pods. Goodbye. And they'll restart pretty quick, but it's going to cause some havoc for our Canary version. They won't work. And let's see if we still have any, because once we've killed all of the pods, and it does it. It's Kubernetes. Oh, they're all come back. Kubernetes has this sort of exponential restart thing where it will take a little bit longer to restart every time you kill the pod. But we've probably killed it enough times now that it will say, we don't like this version that you're sending us, and it's going to kill the Canary version. Hey, this Canary doesn't work. We got to get rid of it. So this health check is going to fire off here in just a second, and it's going to say those yellow pods, they die too much. We don't want them. And there it goes. It has failed because we made it fail. It has now removed the Canary from the network. And if we reload this, we will see red and blue as we started, no yellow. All right, so let's do this again. And what we're gonna issue a fix to it. There were a lot of people that really wanted it to finish. My fix is just going to be to add a space and kick off the pipeline. I could just restart the pipeline, but this will work well too. Issue a fix for our Canary release. All right, and this time while that's running, what we'll do, maybe we'll modify the deployment so that we can see that there are 4 colors that are happening. But let's look just briefly at the Istio configuration. In Istio, they have a tool called Istio Control, and I'm going to get my virtual services, and you'll see that there is a virtual service for colors that is handling this networking. I believe now I can do this with my kube control command. There it is. So this is because there is a custom resource definition for this Istio entity. So let's do get virtual services, service colors, output this as YAML, and you'll see how this is configured. Basically, the way this virtual service works is it sets a gateway. And if you go to colors.multidemo.codefresh.io, you'll be able to see the app that I'm using right now. And it has a destination here. And don't go click on it. If you're doing it, you'll make it fail. We're gonna let it finish, so don't click on it. Right now, it's setting everything to this one instance. Now, depending on where we're at with our build, we'll see that this is actually going to be modified. Now, it's still edited in. Now, there is another entity here called a gateway. Yes, and if we output this, it will show us that it is it's listening for a host, and then it's basically just saying that it can be exposed as expected. So those are the Istio entities, and when I first built this demo, you actually couldn't modify the Istio entities using Helm or kube control. You can now, so you can actually build this potentially into a Helm chart. But you do need the rollout logic that that Codefresh is executing here to make the releases happen. And I'm probably going to do another webinar here on modifying Helm charts to deal with multiple deployments at the same time. But that's a whole other topic. All right, so we've kicked off this Canary validation, and actually, if we look at the virtual service now, what you'll see is that it's routing between two different elements. So here's, this one is getting 65% of the traffic, and this one is getting 35% of traffic. So again, we're going to see 35% of these are going to be yellow. Now we're going to do the same thing again, and we're going to edit the deployments just on cluster 1 of our new deployment. Now notice that these have different amounts of pods. If we were just using Kubernetes, we wouldn't have the control to say only show the these versions 35% of the time. It would just route based on what was there. So we're gonna, oh, whoopsie. We're gonna edit this, and we're gonna modify the color of the new version to be distinct, so that we'll be actually able to see every instance of the application that's being served right now. We have to be quick, otherwise our Canary will finish and we won't be able to see what happens. And value is going to be, let's go green on this one. Okay, now we'll look at the deployments, and this will be available in, you know, half a second here. Okay, it's available. So now we should see 4 colors. There it is, right? Now in our Canary release, we've gotten to the point where 70% of the traffic is getting the Canary releases. Now, if you remember from when we started at the very beginning, cluster 1 is our original deployment. Red is our original deployment on cluster 1. Blue is our original deployment on cluster 2. Yellow is our Canary version on cluster 2, and green is our Canary version on cluster 1. And if that feels like a lot to keep track of, it is. So don't feel too bad that it's a bit that there's a lot of colors. Basically, it means we have 4 instances of our application, 2 on cluster 1, 2 on cluster 2, and we are load balancing between all of these, doing health checks and rolling forward versions as we go along. And again, we could reset our Canary release to the version of that's all just the same colors, right? We can do that using Helm. Oh, and people are still seeing this poll, so sorry about that. All right, so this has now got to 100%, and so we're just going to see yellow and green now. Okay, yellow representing cluster 2, green representing cluster 1. Of course, in the real world, we would just keep these the same, so people would just get the same experience. But for a demo, I find that it's helpful to modify the colors so you can see what clusters are serving stuff. Now, while it's doing that, actually, this will finish a final rollout, and let's answer a question or two while we're going. One question was, will you be using GitLab? I will not be using GitLab. I'm using GitHub. I could use GitLab for the code portion. The CI/CD portion is all handled by Codefresh here. So good question. Another question that's here is, if I have a Helm package and I have the package deployed in 10 namespaces, for example, can Codefresh update all namespaces that use that package as part of a pipeline? Yes, absolutely. It would just be part of a normal deploy step like we've used here. So that would be relatively easy to do, actually. You just have to make sure that you have, you know, your Kubernetes instance that you're exposing to Codefresh. If I go and look at my Kubernetes clusters here, you can see I've got a number of clusters here. You just need to make sure it has the proper permissions, and it will be able to run appropriately. Great question, and again, feel free to ask these questions as we go along. Now, there was a question here. This is multi-cluster but same cloud, correct? Yeah, this is this demo that I actually built is using 2 clusters that are on GKE. However, there's no difference in how we would roll this out to clusters on lots of different places. It would look exactly the same as what we've built here, so there would be no difference. Good question, but maybe something worth building. Let's look here now. So we've finished our full release, and so we just have our green and yellow instances. Now let's go to our Helm releases, and we'll roll back. We'll look at the history here, and we'll roll back to the current revision. Now, for those that are playing along here, we started with this basically version 46, which represented just our normal production application. Version 47 represented both our production and our Canary versions of our application. And version 48 represents only our Canary, which has now become the prod. So we actually stage this as 3 different Helm releases, but we modify Istio outside of that during the ramp up, so that we don't have to have like 15 releases in order to get through everything for every ramp up that we're doing. We just have 2, and then we can just roll it up from there. I'm going to roll back to the current revision, which will get rid of my change that made things green, and everything will just be yellow. So this is how this configuration works. Now there is another entity when you're setting up multi-cluster that you have to set up. There's a secret in here, and it is marked. Oops. There we go. It is marked this istio.default is actually a basically tells it how to talk to cluster 2. Oh, actually, get secrets Istio system, I think is what it's called. Oh yeah, there are a bunch in here. One of these will be so we can talk to cluster 2. Here it is. This is our cluster 2 secret. So basically the way that you connect these clusters, once they can talk to each other from a networking perspective, you need the Kubernetes, service discovery to work properly. This is where Istio is coming in. And the way you do that is you just add a secret to your cluster 1 that has the information for how to connect to the cluster 2 Istio instance. And so it's sort of authorized. It's basically like a key that lets it start routing traffic over to cluster 2. And if you put those keys on both clusters and you have the full control plane on both clusters, you're now doing cross cluster instead of multi-cluster. So you can actually come in through any cluster and access both the services. We're doing multi-cluster. We come in through cluster 1. We can access cluster 1 and 2 deployments and services. One other thing I'll show you on the rollout here. Let's see. I thought I modified this to roll it back, but it looks like I left the version green for some reason. I remember why that would have been the case. But let's do this. This actually works better for the demo I want to do. Let's look at the deployments again. And we're going to delete this deployment that we'd modified. And again, what we'll see is that it's immediately ejected. So there shouldn't be a service interruption. We'll just see a yellow version of the application now, right? So it's all coming from cluster 2. We can actually go beyond that and delete the service that's here, right? So we can take the service that exists and delete it on cluster 1. And we will actually see Istio just starts routing it to the second service on cluster 2. So we've lost our entire infrastructure on cluster 1. It's still serving from cluster 2, no problem. And now at this point, if I do a rollback, we'll see everything will just stay the same color. Awesome. So we've successfully done this multi-cluster, rollout, CI/CD rollout, and had our health checks function the same. The app that I've used here is called Color Coded. It's one that I made. It's on GitHub. The instructions for how to set this up are not good enough yet. And for those that follow me on Twitter, you'll know that I was tweeting yesterday about how sorry I am that I haven't made the instructions better. I will do that soon, so you can follow along there. And I'll answer questions. But before I answer the questions, go ahead and create a free Codefresh account and try this stuff out. You get 120 builds a month free. You can create pipelines. You can manage the Helm releases. You can do so much more. So much is baked in if you are a Kubernetes, if you're building Kubernetes applications, Helm applications, containerized applications. You can build stuff that's not containerized also, but that's kind of what it's designed for. Codefresh.io to go do that. So let me answer some of these questions while this rollout goes through. well, I guess we can, it's probably finished. So we can just go back and look and we'll see both are yellow because cluster 1 and cluster 2 are operating properly. Oh, I was going to show you one other interesting thing. This is just kind of fun. If we kill the deployment again, the health check on cluster 1 will report sort of a funny message. So it'll say there's no replicas, but if we look at the status, it will actually show that replica sets are available because it's them from the second cluster, even though the pods are gone. It's just so it's just sort of, if you're doing a multi-cluster, you may see, that's one thing you might see. Anyway, okay, so let's answer these questions. This one I answered. What are the benefits of using Codefresh over using Spinnaker to drive deployment workflows? Well, there are a couple, and we actually have a whole blog post on this that I would recommend that you look at. If we just go to Codefresh Spinnaker, we'll see this is probably the first result here. Yeah, so we did a whole blog post on this, and I would encourage you to go and read it. There are a couple of things. One, the Kubernetes support and Spinnaker is currently beta, and there's actually 2 different competing standards. So it's not quite standardized yet. There's no Helm support in Spinnaker. You have to pre-render your Kubernetes configuration, your Kubernetes YAMLs, and then deploy them. So you don't get that Helm native workflow. And so you don't get that revision history that you have natively built into that's going to be exposed, right, in Codefresh and through Helm. So that's a pretty big one. On some of the things, the kinds of rollouts that you do in the health checks, our deploy steps, our Canary and blue-green deploy steps for plain Kubernetes or Helm, I think are very good. They work really well. However, our built-in stuff for Istio isn't quite there yet. It's actually what I'm showing you today is the basis for what we're building as built-in steps to work with Istio to do blue-green and Canary automatically. You can take my example and implement it in Codefresh, but it's not quite the drag and drop, point and click experience that it will be probably in 2 weeks or so when we release that image, which it's being worked on right now. But that's a good question. Another thing with Spinnaker is that it does rely on Jenkins to do a lot of work, and with Codefresh you can do the whole workflow on Codefresh. And one example of this that I like to point out is, if we're looking at, let's go to cluster 2 here. If we're looking at this service and we wanted to know where it came from, I can actually just click on this and it will show me the image that's currently running. This one doesn't have any tests associated with it, so there's no log sitting right here, but you can actually have tons of annotations here. You can see that I'm the one who actually did the commit, who created this image in the first place, and I can jump straight to the commit SHA to actually see what change was made in order to build this image and push this commit. This is the one I did during this demo. So there's an amount of traceability that's that you don't have with Spinnaker. Also, this is fully managed, so I don't have to go around managing like a Spinnaker installation. I can access my logs and then all of the image layers. There's a lot of stuff here that's designed around containers that you just won't find in something like Spinnaker, which wasn't really designed for that. Next question is from Romain. Is Istio assigned and configured to a specific namespace, or every deployment can reach any namespace as only one Istio config is in place between the 2 clusters? So this is a really good question, and it's kind of complicated, but basically cluster 1's Istio instance is talking to cluster 2's Istio instance. So cluster 1 Istio will have access to anything that cluster 2 Istio has access to. So I believe that, so for this deployment, for example, it's set up using a matching namespace structure. And I think that if I put the deployment in a second namespace, that it wouldn't be able to reach it because it's not set up to expose that. But that's a good question. I might be wrong about that. I have to think about that. Maybe run some experiments. Good question, Romain. Brian asks, does Codefresh have a manual SIR step in order, for example, to approve the release and deploy to production? Yes and no. This is an area that we're actively developing on, and it's going to be, it'll be really, really cool when we release it. I can't say a whole lot about it, but for manual steps, there are a few ways to accomplish it. One is that you simply serve up your Helm chart inside of the built-in Helm chart repository. For example, I've got one here that's called demo chat. And once it's been updated, you would have the manual step of installing it into the existing version, existing cluster you have. The thing with this is that it requires that all of the values kind of be set. You could potentially override these values when you go to deploy into production. So that's one way to do it. Another way to do it is to have a staged out pipeline that requires a manual kickoff. And so you can do that either with from Slack, a Slack command that approves the release and then goes ahead and finishes it. You could also just have it you have to go in and click run on the pipeline to release it. Another option is you can have a trigger based on a promotion. So for example, when you're setting up a pipeline, you can set up lots of triggers to run. This one's set up to run every time I do a commit to one of these branches, but I could add a trigger so that when registry change happened, it will actually do the release. So that would be a way to do a manual approval as well. So there are kind of a lot of ways to do it. What we're building right now is, I would say, a little bit more straightforward and sort of oh yeah, you just drag and drop the release to push it to production. That's kind of the direction that we're going. Great question from Brian. All right, Jagadish asks, can we see image layer differences? Oh, between images. That would be really cool. No, you can't see the differences between images, but I can look at this one and see the layers, and then I could open up another window and look at a different one. But there's not a diff for the layers. There is a diff for the Helm packages. So if I look at my Helm releases, you can actually see the history, and you could drill down into a diff of what's changed between releases. Great question from Brian. So with that, I have one last question before we close. And again, I would encourage you, go to codefresh.io, create a free account, play around with this stuff. We have a chat button there that you want to ask questions, click on that chat and ask questions. We have a great support team. They love helping people out. So with that, let's answer this last question. For later, regarding marrying Kubernetes, Helm, Istio together, reminds me of Knative. Do you plan to use Knative for Codefresh in the future? So we actually do have a lot of people building serverless with Codefresh. How we expose that is somewhat of an open question, but there's nothing to stop you from using Knative inside of Codefresh today. That would be perfectly reasonable to do, and we'll explore how we do it in the future. And Anja, if you have any ideas for things you'd like to see, send me an email, dan@codefresh.io, or hit me up on Twitter. On Twitter, I am todaywasawesome. Just remember how you felt about this webinar, and that you can remember my name. It is Today Was Awesome. So with that, I do ask that you fill out one more poll, which is the how was this webinar poll. This helps us decide, this helps us know if we did a good job and if we should modify things in the future. And really appreciate everybody joining. I'm gonna double check the chat. We answered all the questions on Facebook.
I think we might have one more question on the chat, Dan, and it was, is there any way to make image scanning during build and stop deployment, or is this out of scope?
Oh, yeah. Totally. So we, what's the best way to expose this? We have, let me show you one of these. In our events page, there's another video we did with Twistlock on this. But this, you could use this with Claire or any other image scanning service. You can add a step that basically scans and decides if it should go or not. So this one is introducing security feedback loop to your CI pipelines. And basically it just has a step before this stuff that we did that does an image scan. I have another demo that I do. Actually, Taryn, let's schedule a webinar on pull request workflows, because I actually have a Claire scan in that one. And I can do just a whole video about that, but I'll just show you an example really quick. It's on different account. We have multi-tenancy. It's part of our role-based access controls here, so I can actually switch contexts. And in this one of these images, I want to say it's this one, has a Claire scan on it. So there's this actually Claire security scan that has been done on this. And I think there's a version, maybe one of these ones that has it uploaded. Yeah, so this one actually has a Claire security scan report that's been added to for me to look at, so I can actually see the full security report. But I basically have checked, done a security scan. So there's checking Docker image against Claire. And I think the rules that we set on this particular one said there's some variants that it allowed. So there are 13 high vulnerabilities. So maybe we should set it lower to fail the pipeline. But that's basically what you do, is you have a step that does it. And this one is relatively straightforward. So great question. Taryn, let's do a video just on the whole pull request workflow. And that has a Claire scan, and it has a security check in it. So that's a great question.
Sounds cool. Good. We'll get that on the schedule. So if everyone will just check, codefresh.io/events, then I'll get that webinar and all of our upcoming webinars and meetups on this page, and past meetups as well. As you saw, Dan was scrolling down, you can view our past webinars.
Well, thank you very much, everybody. We appreciate you joining us, and we'll see you next time.